Today we are going to talk about periodicity. The elements that we are focusing on are lithium, boron, and neon. Today we are going to talk about groups such as metals, nonmetals, and metalloids, families, patterns in electron configuration, the comparison between atomic radius, electronegativity, ionization energy, and the explanation of patterns between nuclear charge, shielding, and energy levels. You can see pictures of the three elements to the right.
When they were creating the periodic table, they placed elements in similar groups called families. In the picture shown to your right, you can see all the groups. Lithium is an alkaline metal family. These metal properties are highly reactive, which means they are never found in elemental form in nature. Reactivity increases as you go down the column in the periodic table. For example, potassium is more reactive than lithium. Lastly, they are silvery, soft, low-density metals. Boron is a semimetal. In the next slide, we will further talk about the semimetals. Neon is in the noble gas group. These gases are unreactive, which means they are very stable in their elemental form. They can form compounds but don't like to. They are mostly used in lighting. For example, argon is used in neon tubes to make neon lights.
When they were creating the periodic table, they placed elements in similar groups. Right now we are going in depth with three groups that are metals, nonmetals, and metalloids. Lithium is the metal we chose, and metals have similar properties such as shiny, ductile, malleable, moderate to high melting points, good thermal and electric conductors, and metallic characteristics. Our nonmetal is neon, and nonmetal properties are the opposite of metal properties, such as dull, which means they are not shiny. They can be solid, liquid, or gases. Brittle if they are solid, have low melting points, and are poor conductors of thermal and electric energy. In each group there are exceptions. For example, carbon is a good conductor of electricity but is a nonmetal. Boron is a metalloid. They are a mix of metals and nonmetals. They have properties of both. They can conduct electricity but not as well as metals. In the periodic table shown, all gray elements are metals, all golden elements are nonmetals, and the blue elements create a stair step which indicates that those are the metalloids. In the picture below, the left are some examples of metals. The ones to the right are examples of nonmetals, and the ones on the bottom are metalloids.
Electron configuration is quicker than writing down an orbital diagram for elements. Orbital diagrams include arrows, which can get a little messy and unorganized. To write down electron configuration, you write the energy level and the letter for each sublevel, and the number of electrons is in the exponent. The picture to your top right shows the order you write the energy levels. You can see that we fill 4s before 3d. This is because 4s is lower energy level, and we finish those first. The periodic table shows which section has higher sublevels. Here, it better visualizes why we finish lower energy levels before higher ones. Valence electrons are found in the outermost energy level, with the sublevels S and P only. This equals a maximum of 8 valence electrons. The sublevels have a max of 2 valence electrons, and the P has a max of 6. Adding those two together gives us our 8 valence electrons.
Atomic radius is the distance from the center of the nucleus to the edge of an electron cloud. As we go down a group, atomic radius increases. This is due to the fact that there are added energy levels. As we go across the period, the atomic radius decreases. This is because electrons are added to the energy levels and shielding is occurring. Electronegativity is the tendency for an atom to attract electrons when chemically combined. This is their desire for electrons. As we go down a group, electronegativity decreases because the valence electrons occupy a higher energy level. As we go across a period, electronegativity increases due to the nuclear charge increasing as you go across a period. Ionization energy is the energy required to remove an electron from the outermost energy level. In other words, it is how strong an atom holds onto its electrons. The easier it is to take an electron away, the weaker the energy is, and vice versa. The harder it is to take away an electron, the stronger the energy. As we go down a group, ionization energy decreases because the electrons are further from the nucleus due to more energy levels. As we go across, ionization energy increases because atomic radius is decreasing, so electrons are held on more tightly. In the picture of the periodic table, it clearly shows the different electrons growing and shrinking in the different element growing and shrinking in size. The biggest being cesium and the smallest being helium.
Lithium, boron, and neon are all in the same row. Shielding is when the pull of the nucleus on the valence electrons is shielded or blocked by the inner electrons. Electrons are added to the same energy level. Shielding is consistent across the row. In the graph down to the right, you can see that lithium only has 3 electrons, so the valence electrons can still feel the pull of the nucleus. However, potassium has 19 electrons, which causes the valence electrons to be further away from the nucleus, decreasing its pull. Nuclear charge is increasing, and this pulls all electrons closer to the nucleus, which makes the atomic radius small. Electronegativity increases, and ionization energy is stronger.
And these are our works cited.